Hi, okay, so this is just a video on how to make the protein the enzyme simulation lab. Okay, the because some of you if you weren't here last week, so I'm going to show you this YouTube video. You need to learn how to do it yourself here. Okay, so all right, so first of all, this enzyme simulation lab, we are going to, you can download it from your lab canvas right under home, and then worksheets for lab exam one. So just download this enzyme simulation lab Excel file. So you just download it first. Okay, and then I will show you how to, it should actually contain the instructions on how to make the graph afterwards. Okay, so let's just open that Excel file. All right, so now it's open. All right, okay, so once you've opened the Excel file, all right, so I'm going to put half screen here because we need to open this software. Click on enable editing. So you need to open this software, open this website in order to actually do the exercise. Okay, so copy and paste this link over here, and then we will go to put onto a browser. We'll try to generate some data from that website, and then we are going to record the data here. Okay, so just copy and paste that. All right, so I'm actually going to keep a half a screen. Okay, so that I can enter the data as I'm generating data. Okay. All right. So you can see here, this is actually the experimental setup, which is a online experiment. But then, so this is using an enzyme lactase to break down lactose into glucose and galactose. Okay. And there's a glucose sensor here that is actually measuring the amount of glucose generated. Okay, and it's expressed in a unit milligram per deciliter. Okay. All right, so we will be using this software to generate the experiment. You can actually see here, you can play with the parameters of the software. So we're just going to keep the data, keep the parameter, we keep the other parameters unchanged. We're only going to be altering the concentration, okay? So we'll only be altering the concentration. Let's keep the temperature 25 and keep the pH at 7, okay? All right, so we'll be using this. I am doing a split screen here so that you can record the data as you are moving along. Okay, so we're going to be recording the data onto the Excel sheet as we are generating data on the software. Okay. All right, so here is the parameters. So first of all, you can follow the instructions here. We've downloaded. Set the lactose concentration to 100. Okay, and we type 100 here. It says, and then you want to hit run 3 times. Okay, 1, 2, 3. Okay, now that actually simulates, repeating the experiment 3 times. And then we are going to record the data of these 3 separate runs of the same concentration. Okay. All right. So then the instruction here, step number 4 here, slide the bar to minute 7. Just click on around minute 7. Okay. It says minute 7. Now you notice the minutes on minute 7, it says run 1 is 85.4. Run 2 is 73, and run 3 is 83.7. So you need to record these 3 data onto the worksheet over there. Okay, so 85.4, 73, 83.7. Okay, so I'm just going to type 85.4, go back here, 73 and 83.7. Okay, so 73, 83.7. All right, so now you've done one concentration. So we are now going to go to a different concentration. So please keep the, now we've done number 5 here, record the data. Now you need to go back to your software, hit the reset button so that you get rid of the data. Now we're going to change the concentration, set the concentration to 200, 200 now, 200 milligram per deciliter now. Then we also hit it 3 times. Okay, so hit 3 times, repeat that, hit it 3 times. Okay, repeat steps through to 6. Okay, hit it 3 times. All right, so once you've done that, you can see here, go back to minute 7 as well. Now record these 3 data onto the 200. Okay, so now when you generate your data, it's going to be different. So this software actually has some built-in, variation, so that every time you actually click on the concentration, it generates. It's like an independent trial run, so it generates different data for you. So when you do that yourself, you're going to get different data. Okay, so that's the whole. That's why I like this simulation software, because it actually generates different data for everybody. Okay, so all right, so these three data that I got from this is 151, 159, and 163. Okay, so 151, 159, 163. Okay, so 151, 159, 163. Okay, so that's our 200. All right, now you go back to the software, reset it. Now just go to 400. Okay, and we got the same data, hit run 3 times. Okay, so I'm just going to do it quickly as you get the message. So go back to minute 7. So now I have 307, 318, 299. Okay, all right, so I'm going to record here 307, 318, 299. Okay, all right, so now feel free to incorporate more runs if you like. Okay, the average and the standard deviation will be better with more trial, but minimum 3 times. Okay, so we're going to reset it now and change the concentration to 600. The next concentration, also hit this 3 times, run, run, and run. Okay, now you can see that the rate has significantly increased. So now I'm going to also point at minute 7. Okay, now these three data are 407, 405, 405. Okay, so I'm going to record 407, 405, 405. Okay, now we'll go to 800. Okay, 800. And sorry, reset it first, go to 800, and then we'll hit run 3 times. 1, 2, 3. Now also click at minute 7. Now now I have 503, 509, 454. Okay, 503, 509, 454. Now your three data, once again, will be different from the three data that generated this software. Every time you hit it, it generates a different data. Okay, so yeah, you see. Anyway, so now reset it, and then you go to 1000 now. All right, and then you hit run 3 times again. 1, 2, ooh, a lot of variation this time. All right, so I'm getting 395, 703, 593. Okay, 395, 703, 593. 395, 705, 593. Okay, so 395, 703, 593. Okay, so all right, so now we have generated the data. You can actually now close this enzyme simulator. Okay, we won't need this anymore. So I'm going to minimize it, maximize the screen so that you can see the bigger screen for the generating the graph. I'll make it a little bit bigger too. All right, so now I put an instruction here. The value recorded is actually the amount of glucose after 7 minutes. Okay, so to calculate the rate, we actually formation per second, you need to divide each of these data by 420. Okay, so divide that by 420. 60 minutes times 60 times 7, 420. All right, so this is what you do. So and you notice I've actually put in a match area for you. So what you need to do here is you to divide your data by 420. So click on this first square first. All right, click on this square here, and then hit the equal sign. You always need to hit the equal sign first if you want Excel to do any calculation for you. Okay, so then click on this data 85.4 here. The first data it also says C19, and then hit this downwards upward slash, I would say, from down to up. Left to right, and then that's the dividing command for Excel, and then divided by 420. Okay, so type that in 420. All right, so once you have made one data like that, okay, you can copy and paste the next data. So the next square, you do not have to do the repeat typing in, the same command every square. Okay, so now Excel has a beauty that if you can just right click and copy, or hit Control C, that will be copied. Okay, and then go to this square, and then you click right click here, and then you hit paste. Okay, now the first paste, regular paste. Okay, I'll show you the difference between all of these various places. So the first place is regular pasting, that includes the formula. The second one is just value. Okay, the second one only place the value next to it. So select the first one for this command. Okay. All right, so now also one more trick, you can simply say Control C, Control V. Okay, so that would also be copying and pasting, okay? Now, once you've done one column, you can actually just highlight it. Let me show you another trick on Excel that you can quickly repeat the same command in the next column, okay? So instead of typing, the next column, the same command, you can actually, now you see here, if I am right, if I just click on this square, all right, and then if I go to the bottom corner, when the arrow turn, when my little cross turn to a small black cross like that, from being a white cross to this black one with the long arrows, and now you go to this one, you see a smaller black cross. Click and hold, and then you can now start dragging the command to the next box that would actually repeat the same command for you. You can actually check it. You can see here when I click on this second square here next to the 200, concentration is now C20 divided by 420. C20 is this square, okay? So now you're dividing that by 420, okay? So you can also drag that sideways as well, okay? You can highlight the whole column like that and go back to this very right corner. When it changes this little black arrow, you can actually just drag it to the next square, drag it to, it will then actually copy the same command all over, okay? So, right, so make sure your data is correctly, okay? You can just do copy and paste, or you can just drag it like that while clicking the lower bottom, okay? So, all right, now we have done the but now we've calculated the rate of glucose formation. All right, now we need to take a reciprocal, okay, because we are actually going to plot 1/v versus 1/s, okay? So now, okay, so I have inverted this for you, but you may as well try it yourself, okay? So you should do it yourself too. So reciprocal equals, okay, and then this, okay, sorry, reciprocal is simply 1/. Equal sign first, 1/, okay, 1/100, okay, and you can try the same thing over here, okay, so we need to invert all of these to invert all of these data. So, okay, so click on this, hit the equal sign, and then 1/, this one, okay, all right. As I said, once you've done one, you can just drag to the other one. That's what I like to do. Or you can copy and paste. Okay, copy, go to the next square, paste. Okay, so that will also copy the same number. Same here. You can just go to the right corner and drag down. All right. Or you can just say copy and then paste to go to the next square. Okay. So Control C, Control V. Okay. Now here you can see I can just move the drag over here, or you can just, copy as well. You can right click. There's several ways to do it. Right click, copy, and then just Control V is paste. Okay. Or you can go to this paste. Okay. That would also paste to the next square. Okay. Or the simplest way is to just go to the right corner and drag to fill up the square, okay? All right, so if you notice any unusual data, click on some mixture that is showing 1/, the corresponding square, okay? Because we're generating the reciprocal from the table above, okay? All right, now I set down here now, copy and paste the lactose value using paste formula. Let me show you how to do it, okay? And here you want to highlight it, you've copied, and then you want to say copy. And then here, I mean, I've already done it for you, but if you want to do it yourself, know how to do it yourself, that's what you do. So you copy that there. Yeah. And if you want to do paste value, you go to the second command that says value. Or you see this 1, 2, 3 icon under paste. Okay, paste option. The first one is just pasting the formula. The second one actually pastes just the value. Okay, it means just take the value and just now paste the value. This is a very useful command. I do want you to learn it, okay? But sometimes you don't want to copy the formula over, you just want to copy the values, okay? That's a very useful feature, actually. So let me show you. So if you get copy but paste value, you see now only the value is pasted. So now you can see here the value is actually just the value, okay? There's no longer a formula. If you click on this one, this is actually the formula, okay? So all right, so this square, we want to compute average of the 3 rates of the same concentration. This word. So the average command, you hit the equal sign first, AVERAGE, okay, open the bracket, and then select just the 3 concentrations, okay, sorry, the 3 data of the same concentration. So, okay, the 3 data of the same concentration. So just these 3, okay, and then close the bracket, hit the enter sign, okay, so that's how you generate average, okay. Now I'll do it one more time, and then I'm just going to drag for the rest, okay? So do the equal sign, AVERAGE, All right, and then open the bracket. Now, just the corresponding three data of the same concentration. Okay, just the three data of the same concentration. Select that range and then close the bracket, hit enter. Okay, so now I've done these two and I can just drag for the rest and then even after you've done one, you can just drag and then you can then see that you are now calculating. You see, I click on the last one, is averaging now C44 to E44. That means I'm averaging this. Okay. All right. So this square, we need to calculate the standard deviation. Okay. So the standard deviation combined is equal sign as TDEV dot S. Okay. So that's we want the estimate the standard deviation based on sample, ignore logical values in text in the sample. Okay. So these are clearly sample data. So we want to use that command, stdev.s. Okay. Now, please don't use there is a stdev.p. But this one said calculate deviation based on the entire population. So we only have 3 samples. So we want the one that says std.ev.s. Okay. You open the bracket as well. And then you also just want to highlight the 3 data of the same concentration because you want to calculate standard deviation just of the 3 data of the same concentration. Okay. Okay. Do not highlight the entire table. Just calculate the standard deviation of the 3 data of the same concentration. And you close the bracket, hit enter. Now, once you've done one, you can then drag to recalculate the rest. Okay. All right. So now we are going to plot 1 over v versus 1 over. This is 1 over v. This is 1 over s. Okay. So this is the 1 over 1 over v. Sorry, 1 over v is the rate, 1 over the velocity, and then 1 over s is 1 over the lactose concentration. Okay. So now we're going to generate 1 over v versus 1 over s. Okay, which is 1 over the average rate and then against the average of the rate. Okay, so against the lactose 1 over lactose concentration. Okay, all right, so it's actually relatively simple. You just highlight to generate an XY scatter plot. You just highlight the data. You can include the heading or you can do it without heading. It actually won't affect the result. Okay, so Excel can tolerate one heading. Okay. All right, so to generate this graph, you need to insert the right type of graph because we need the XY scatter plot. Now, this is actually where I find some students actually easily make a mistake. So when you insert the type of graph, make sure you choose the right type of graph, not this line. It says insert line chart. No, not this line chart. We want the XY scatter plot. Okay, XY scatter. Make sure that you are selecting XY scatter. Okay. Now, within that plot, since we're generating a regression plot, we just need the one without the lines. Okay, now this is the one with line, but we actually want the one without line because we want to show a trend line afterwards. Okay, so use the one without line for this particular exercise. Okay, so all right, so you see here, once we've generated the graph, okay, you can make it a little bit bigger so that you can see it a little bit more easily. All right, and now we're going to try to see what's on the graph, okay? I put down here, insert trend line, select more options, and auto regression, click on error bar, add some error bars. We're going to show you how to do all of that, okay? All right, so first of all, let's insert the trend line. So we're going to click on this green arrow. Now this thing will pop up either on the left or the right, depending where you put your graph. If you put your graph here, you click, it will appear on the right. And if you put your graph these to the left of the screen, you click here, that appears on the left, okay? All right, so now let's go to this trend line first, okay? You want to click on the trend line, insert the trend line, and then click on this little arrow after the trend line, okay? And then select more options, okay? More options. Once you select more options, make sure you have 3 different options. You may not actually always be on the same spot, but click on this graphical icon here. Okay, so it may actually be here, but then remember to click back on this graphical icon after you've selected more options. All right, so leave the graph as linear, that's correct. But now we need to come down here and say display equations on chart and display R square, okay? All right, so then you can close this afterwards. Now, R square is a measure of how well correlated the data is, okay? R square of 1 means the data are perfectly correlated, therefore all on a straight line, okay? So we got 0.9988. It's actually pretty good. You can see that they do fit on this regression line pretty well, okay? So this is the regression equation generated by Excel, okay? Y equals 498.6x plus the 0.2115. And so we will be using this equation to calculate the using the first area is a slope. Okay, so same. This is the first number here, 498.6 is actually the slope. And then this 0.2115 is actually the y-intercept, okay? Meaning the y-intercept, meaning, well, when this 0.05, meaning when x is 0, that hits about, you can see that it does project to approximately 0.2115. That's the y-intercept. When x is 0, you can see here, this will probably project down to 0.1225. So this is actually the y-intercept. 0.2115 here is the y-intercept, okay? All right, so this is the graph that we need. Okay, now let's actually fix the graph, put in the error bars. Okay, so it looks a little bit nicer. Okay, all right, so now I'm going to activate the axis title 2. Okay, now always label your axes because you do want to know what you're doing. Okay, so the y-axis is 1 over v, the velocity. Okay, and x-axis here is 1 over s, okay? 1 over s. Now, since we're doing a reciprocal, you don't need to put in a unit. 1 over s, that's fine, okay? So since doing reciprocal is going to become an arbitrary unit, you don't have to, say that the unit has been inverted as well. So just skip the unit, but 1 over v versus 1 over s. Now, give it a nice title here, okay? So this is you can simply you can say 1 over v versus 1 over s, okay? Or you can call it double reciprocal plot, okay? Double reciprocal plot, okay? All right, of enzyme activities, okay? Of the, okay, of lactase enzyme, sorry, double reciprocal of whenever v versus lactase enzyme activities, okay? Activities. All right, so now we are done with plotting, and then let's generate the error bars right now, okay? Error bars, that's the most tricky thing, okay? And now we need to incorporate the standard deviation data value that we've calculated onto as error bars on the chart, okay? There's only one good way to do it. Please watch carefully here. There's only one way to do it, and you must be able to do it this way, okay? We want to incorporate these standard deviation data as the error bars, okay? So here's what you do. Click on the chart elements, okay? Now activate the error bar function now, okay? So activate the error bar functions. Now, once you've activated error bar, it looks very funny, okay? It's like, it's got a little cross on it, okay? Don't worry about it. We'll fix it in due course, okay? So let's just click on the arrow bar. Now you click on the right side, select more options. Okay, click on this little arrow and select more options. Okay. All right, now we need to fix the error bars. Okay. All right, now let's take a look. Okay. Now you may be at this icon or this icon. Make sure you are at this icon. Okay. So when you're at this little bar chart icon, now let's go to the part that says error bar options. You can see here it says you can do series X error bar, and you can also have Y error bars. Okay. All right, now X error bar is the error is actually the x-axis. There's actually so select the X error bar first. Okay. And so for X error bar, we actually don't want any, okay? There should not be any X error bar. So the easiest way to get rid of the X error bar is simply to say, I want a fixed value of 0, okay? Just enter 0 here and hit enter, okay? So now you've got rid of the X error bar, okay? Remember, X is the independent variable on over S here. You alter the concentration manually. There should not be any error. It's not a measured outcome, okay? So the measured outcome is usually on the y-axis, always on the y-axis, and then the independent variable, the variable that you changed, okay? So we manually change to 100, 200, and then we reciprocate them, okay? So that the independent variable should not have any error bars, okay? All right, now let's actually change the X, Y error bar now, okay? So now you go back to the error bar options. Now you're going to select the series average of 1 over rate Y error bar. Just fix the Y error bars. Once you're at the Y error bars, okay, so you can see here, make sure you're still on this graph icon, okay? If you're here, make sure you go back to the graph icon. All right, so now you can see here your couple options too. It says fixed value, percentage, standard deviation, standard error. Now, do not use the standard deviation, standard error command. It's not what we want. We want to go to custom, okay? We're going to do the custom and incorporate these data that we've generated as a standard deviation on the chart. Okay, so now you go to custom, space, say specify value, and this little window should pop up. It says positive error bar with negative error bar, custom error bars. Okay. All right, so now click on the positive first, just get rid of whatever's on it, backspace a few times, and then you highlight this data range, okay, just from, D50, okay, here down to the bottom, just highlight this range, okay? And now do the same thing for the negative. Go to the negative error bar, get rid of the original, whatever is on there, and then select this range, from the 0.456, okay, so that would be D50 all the way to D55, okay, select this range, okay. The upper and the lower error bar value should be the same, okay, and then now you click OK. Now there you go. Now we've generated a graph with the proper error bars, okay. Error bar S is the standard deviation that we've calculated, okay. All right, so that's the bulk part of it, okay. So and then we're going to talk about how to use the graph to calculate Vmax and Km, okay. Okay, so now you see we've generated the graph. We plotted 1 over V versus 1 over S. We're going to use the graph to calculate the Vmax and Km, okay? All right, now we actually discussed it in lecture. So this is in chapter 6, our lecture, okay? And slide 49 here, if you look at this is the Michaelis-Menten equation. We discussed that Michaelis-Menten equation of this double reciprocal plot. A plot of 1 over V versus 1 over S, the double reciprocal plot, okay? Now you see a linear plot takes the general form of y equals mx plus b. M is the slope and b is the y-intercept, okay? Now if you look at this equation, when you plot 1 over V versus 1 over S, okay? The y-intercept is this one, okay? And then Km over Vmax is now the slope, okay? So you can see here, that's what this equation tells us. Okay, now I will give you the equation in the lab exam, but and then you need to be able to calculate Vmax based on the y-intercept, and then calculate the slope. Okay, based on the slope is given to you. Calculate Km based on the slope after calculating Vmax. Okay, all right. So this is once again the Michaelis-Menten equation. The y-intercept was 1 over Vmax. Okay, so if I move this aside, you can see here y-intercept value is the what's split out of the regression equation. Okay, the y-intercept value, let me move the chart a little bit lower here, so because I'm calculating these now. So you can see here the y-intercept value is just based on this equation. Okay, I have for this data set that I've generated, you can see that the y-intercept is 0.2115. So I'm just going to type down here 0.2115. Okay. Now the slope is the 489.6. Okay, now you should have different data. Your slope value and your y-intercept value will be different if you've generated your own data. Okay, all right, so now what we do to calculate the Vmax is simply 1 over the y-intercept. Okay, so once again, here you look at the equation, y-intercept is 1 over Vmax. So you move it over, 1 over y-intercept is the Vmax. Okay, so now you just simply calculate 1 over, that will give you the Vmax. So this is, okay, 1 over the y-intercept, this one, okay, 1 over y-intercept, that's the Vmax, okay. All right, so now slope is the same. This is 486.5. You just copy and paste this one back over here. Slope is the same as the K. Now slope is actually Km divided by Vmax. That means 498.6 is Km divided by Vmax. Now we just calculated Vmax, okay, not the reciprocal of Vmax. We just calculated Vmax based on the 1 over y-intercept. So slope times Vmax equals Km. Okay, so so once again, from the equation, slope equals Km over Vmax. So slope times the Vmax will equal Km. Okay, so we want to calculate Km. All right, so Km is calculated with slope times the Vmax. So simply, right over here, equal sign. This is the slope is 489, and then times Vmax. Now times is that little is the shift 8. Okay, that star. Okay, shift 8. And Vmax, okay? Vmax is just that one, okay? Right, so don't click on the reciprocal of Vmax. We want slope times Vmax. We've already calculated Vmax. So hit enter. So now your Km is about 2,357 Vmax is 4.28 Okay, so now you've actually completed the exercise. Okay, so so this recording is a reference, so please go and complete the exercise yourself if you missed that. And start with the that software simulation, generate your own data, and then you can follow the same methodology, and then just plot, generate your own Vmax and Km value and the correct plot with the right error bars. Okay. All right. So thank you. I will discuss another exercise in another video.